Okay, welcome. So this will be a quick video, and we're going to talk about linear interpolation. So interpolation is when we're looking at values within a data set, okay? Or within a range of in a data set. So usually in statistics we talk about interpolation. We're trying to predict a value on an X value, or we're trying to predict a value of the dependent variable given an X value that's within a certain range of data. But in this case, what we're talking about is linear interpolation, and in this case it's a little bit different, and what it is we're looking at the value that lies between two values in a table. And linear interpolation assumes that if a value of one variable lies between two stated values, two listed values in the table, then the corresponding value of the other variable is going to be at the same proportional distance between the two listed values in the other column. So let me give you an example. So let's say we have the boiler data again, and so we've got 1 and 2 minutes, and here are the corresponding temperatures of the boiler at those two given times, right? And so let's say we want to know, okay, between 1 and 2 minutes, what was the temperature at 1.4 minutes? Well, what we're going to do is, to find that temperature, we're going to assume that the distance from 1 to 1.4 is proportional to the distance of 142.8 to the temperature, which we're going to call X. Okay, that's the temperature we're trying to find, right? So we don't know what that temperature is. Okay, so what we're going to do is we're going to make a proportion of the distances. Okay, so how are we going to do this? Well, let's talk about distance. Let's do instead of X being the temperature, let's talk about distance. Since distances are proportional, let's try to do this in terms of distance. So we're trying to find the temperature, but we don't want X to be the temperature. We want X to represent the distance from this temperature to the temperature that we need. I hope that makes sense. Okay, so let's look at distances being proportional, right? That's what it means in the definition, right? Linear interpolation. The distances are proportional. So first of all, the distance from this here, let's do this in a different color. So let's do the distance here is 1. And the distance here is what? Well, just subtract them. Then you get 4.3. And now what we want is to relate the other distances, the distances that we're looking for. Okay? So that would mean this distance, which is 0.4, is going to be proportional to this distance. Okay? To whatever this value is. And so we're going to call that distance X. Now X represents the distance, not the value. We're going to use X to find the value though. Okay? This is the value, the question mark. We know that the distance from this temperature to the temperature we're looking for is going to have X, a distance of X. So that's how we're going to use the X variable. So now let's set this up. So that means 1 goes with 4.3, right? So this ratio is proportional to this ratio. And so now we set up a proportion that we can solve. Okay. Let's see what we get. So in this case here, if we solve for x, we get x equals what? 4.3 times 0.4 which gives us 1.7. Okay, now we're not done. Be careful. This is the distance. What we're looking for is the temperature. So what is the corresponding temperature? Well, using linear interpolation, it's going to be 142.8 plus 1.7, which is going to give us 144.5 degrees Celsius. And that is what we would use as our estimated value. And so the temperature, by our measurements, increased by 1.7 degrees from 1 to 1.4 minutes. And so it reached a temperature of 144.5 degrees Celsius. And that's it. Have a great day.